What's up, Cal Gang? Welcome back to statics. So we're doing the center of mass problem. We're trying to find x bar and y bar for this shape here. So let's go ahead and solve it. So we have our two equations. So x bar is this equation here. So we're adding up the individual center of masses times each of their areas and then dividing it by the total area of the shape. And then y bar is the same but in the other direction. So the good thing about this is y bar is how far from this, or x bar is how far from this direction, and y bar is how much from this direction. So first of all, let's just check something out. This shape is symmetrical, right? If you flip it across this axis here, it's going to be symmetrical. So if the shape is symmetrical, it's pretty easy to tell where the center of mass is going to be. We can really easily say that x bar is equal to 6 inches, right? Because this shape is 3 plus 6 plus 3 inches long. It's 12 inches long, and it's symmetrical, so it's just going to be 6 inches is where the center of mass x bar is. Y bar is not so easy because it's not easily symmetrical across the x-axis. So we're going to actually need to use this table for it. So if you haven't checked out my other videos, there's a method I like to do. And basically I'm going to break this up into the simplest shapes that I can. And I think the simplest shapes that I can find for this is going to be a rectangle and 2 triangles. So we're going to label this triangle 1, this triangle 2, and this triangle is 3. So let's go ahead and add them over here. So 1, 2, 3. So I'm not going to do x bar because we already found x bar, so save ourselves some time. Let's do y bar. You can still practice this if you want, just to make sure that you get 6, and I bet you will. So let's do y bar though, because that's going to be the challenge. So y bar prime. So this is the individual center of mass for each of these shapes. So we're going from here, and we have to find the center of mass of this triangle. So this is y bar prime 1, maybe. So what is the center of mass of a triangle? Well, say we have a triangle that looks like this. Our center of mass is going to be, this, and this is 1/3 the height of the triangle. So if the height of this triangle is 4 inches, because it is, this height is 4 inches, it's going to be a third of 4. So that's going to be, this distance is going to be 4/3, right? So you have 4 divided by 3. Because its height is 4, everyone needs to divide it by 3 to find this height. But we still need to add it to this height, which is 2 inches, so it's going to be 2 plus 4/3. So that's going to be equal to 3.33 is going to be y bar of this guy. So again, 3.33 is the height from the bottom to the center mass of this triangle, which is 1/3 of the way from the base of the triangle. So number 2 is the same triangle as number 1, but flipped across the y-axis, so it's going to have the same exact y bar of 3.33. Now the area of a triangle is pretty easy to find. We know that its base is 3 and its height is 4. So we're going to take base times width divided by 2 to get 6 inches squared for each of these. Now the rectangle is going to be a little easier. We know its height is 2 inches, so if we want to find the center of mass from the x-axis, it's just going to be half of 2 inches to get 1 inch. And its area is 24 inches squared. So now it's time to do the math on this. So I'm simply going to plug it into that equation that I wrote up there. So all we're going to do is we're going to multiply this by this and then add it to this times this plus this times this. So we're going to take 3.33, multiply it by 6. And we're going to add to the next one, which is 3.33, multiply it by 6. Then we're going to take the next one, which is 1, multiply it by 24. So that's the numerator. It's just multiplying y bar prime times area prime. Then on the bottom, we're just going to add up all the areas of 6 plus 6 plus 24. You get y bar prime, or y bar, simply, is 1.77 inches. So if we want to write it in centroid form, we're going to write centroid is equal to, we know it's 6 inches for the x and then 1.77 just for the y. And there we go, that's our final answer. So just gonna double check that really quick, but yeah, that's pretty much correct. So that's how you solve these kind of problems, just breaking it up into shapes and then using the equations. So thanks for watching. If you want more practice with finding centroids, check out my channel where I have more playlists and more problems similar to this one where we can practice. And thank you. Good luck on your test, good luck on your quiz, good luck on your homework, and see you in the next video. Peace.